Good day. Today's video will be about battery management system for battery walls, and we are putting together one that is designed by Stuart Pittaway. This is the version 4. I am going to show you how to put one together using a simple soldering iron and just some solder, in case you don't have stencils and solder paste and stuff like that. After that we are going to, I am going to show you how to program these controllers, and the modules we are going to program using an Arduino. So you don't need to install much of anything onto your computer besides some basic Arduino software. So, and also how to solder the tiny SMD chips using just a plain soldering iron. I'm going to skip or speed up the parts that are boring or repetitive. Let us start with the resistors and in general prepping the board. Okay, I will show the controller chip too, but the rest is not so. It's also the same thing that I'm doing here. Now, prepping the resistors, or let's say the pads. I'm going to mostly do just one side on each element, so we can attach it from one side and then deal with the other side. And in case the component has many legs, then one leg for this one and one leg for the 3-legged ones. Now from this bag I can do 3 components. And since I wrote those on the box, I can check from the top of the box where the current ones will be soldered. These were 17, 18 and 23, but I'm going to do all the pads. Now time to place the resistors, and what I usually do is I will sink them into the soldering paste, so they will flow nicely. That's 17. Next pack. I'll take the big resistors next, and we are going to use 8 of these. These are the heatsink resistors that will dissipate energy when your cell packs are balancing. And for these resistors you want to make sure that they are touching the board firmly, that they are completely flat and there is no gap, because the board itself will also spread the heat. So if they are up in the air, they will not be as effective. What I also wanted to touch on is that when I made the order for the parts, I really messed up with the bill of materials file that I imported. So there are several parts that I didn't receive as much as is necessary. So you will see me replacing some parts with hacked together other kind of resistors, for example, and also the connectors for wires. I also only got 10 of these instead of the 50, and that is mostly due to me not checking the order after importing, presuming that everything got added. And since there were so many items that I hadn't bought before, I kind of got an information overload. And discovered the faults later after receiving my order. So these are sourced locally, for example. Now it's time to do capacitors and thermistors and other fun parts. This again must be made sure that it is flush on the board, because this measures temperature. Now it's time for the isolator chip. This has a little marking in one of the corners that goes to the leg number 1 that is up here. Now with diodes I have to talk about the orientation. by which I mean positive and negative, there should be orientation marking on the silk screen, but as I heard from Stuart, the solder pads have covered those up for some reason. And what we can take away from this is that what he told me is all the diodes are left side negative. So this pad is negative, this pad is negative, and this pad is negative. And on the diode you have usually marks on the negative side, like as two little, let's see if I can zoom in, two little red dots on the negative side. And I'm going to show you one more way how to test this. Now if you put your tester into diode mode, which is blue here, and now touch the LED diode with the leads, then if your positive negatives are on the right side, it will light up. If you're doing it the wrong way, nothing happens. So this way you can confirm that yes, my diode also has markings on the negative side. Maybe there are some that don't. Now a MOSFET. This fun guy has 3 legs. So this goes to the Q1 spot, which is Now I realize I have done much of this in silence without explaining much. The point is that I will place the component on the solder and use flat side to push and heat up the solder from the side like this on the board. So the pad gets heated up and then the part too, and it will then run together nicely, which is this now, C2. I can put it on the board, I touch the solder and press it on, and now it is soldered on. Now let's do the fun part, the Arduino, ATTinyTiny. This also has marking. Let's see if you can see it. It is, its first leg is marked with a little dot here, and this goes on the first leg. And like this, it is now in place, and we can continue attaching to other legs. And there we go. And maybe with the little parts with the very tiny legs, you might want to solder all the 3 legs before you attach something besides it, if you don't have very fine tipped soldering iron, or you are not very experienced. These little 3-legged ones might be better to do first, and then anything that goes around it. And same goes for the sides of the resistors. You might want to do both sides before you attach the next one, if you think that the space between is too little for your soldering iron. Oh, and I'm missing the 3rd resistor, because this is one of the parts that I didn't order for some reason. So I'm going to hack it together from bigger resistors. Also, I'm going to solder the connectors, because we need those to program the ATTinyCore. Now for the sensor connector, what I heard from Stuart is that you only need pins 1 and 2, and you can, for the external sensor that is, and you can use the same thermistor by attaching wires to it for external use. Since I'm currently missing those connectors, because I didn't order enough, I am going to replace them with pin headers until I receive the order, and then I'll replace them. Now we need to figure out the R3 resistor that has a funky value of 475k, and I don't have such resistor, so we are going to use these to put one together. One from here, one from here, 475. And there we go. Beautiful, isn't it? Shouldn't be touching anything. Yeah, it's fine. So the board is complete. Let's also show soldering this one. This has the little cut-in mark seen here by, you see the top one. Oops. Here on the top and on the board. Looks straight enough. And done. Now for the controller programming, go to the precompiled binary files page that Stuart made, and from here you can get the flasher program, the NodeMCU PyFlasher.exe, and also you can get the files, the bin file for BMS. Connect it to your USB, open up Device Manager to find out what the comport is. It was COM21. Now when you have the bin downloaded and you have the NodeMCU PyFlasher installed, you need to run the PyFlasher. This is starting up. define your comport. For me it was 21. Now you will pick your bin file from your computer that you downloaded. Don't need to touch the speed and the flash mode. You will touch the erase flash, yes, wipe all. And after that, flash node MCU. And your controller is now programmed. That's it. The next step is preparing your Arduino for programming the ATTinyCore. This will act as the programmer, and you have to upload the correct sketch for this. And this is done by from examples. Take the Arduino ESP. From tools, pick the correct board, which is for me Arduino Uno at the moment. And from device manager we can see it's COM21 again. Now the programmer at the moment should be, sorry, I think it was Mark II. Anyway, now I will upload it to the Uno. And this step is done. Next step is to connect the balancing module header to Uno, and this might be one of the trickiest part to get the wiring correct. I will try to add some pictures of how the wiring is done. Now if your boards are connected together correctly, then you are going to need the ATTinyCore firmware hex file that you can download on the GitHub page. And to install it, we are going to run a command prompt command. I will put the command in the description. You will have to modify it a little bit because it uses folder names that are different because you don't have the same username as I have, for example. And let's run the command now. Now after you have fixed the command line with the proper folder names and comport, then you will just press enter and it will start uploading the firmware. This will take some time. Both the green and the blue LEDs are blinking. And it is done. I do have to add that it wasn't all that simple. Well, you pretty much had to install the latest Arduino software. This gave you the avrdude file and the config file, but my config file didn't have the ATTinyCore 841 configuration for this upload. So I think it is mentioned here, like you must add this ATTinyCore for Arduino. This adds the boards to the Arduino software, Arduino software, the Attini different boards, but it didn't have the one I need here, so I had to add a bit of code to the configuration file to have this 841 even selectable. Well, I'm not selecting it, but the command line just prompted back that I'm sorry, your config file doesn't have such board called 841. So you might have to add this to the configuration file, the avrdude.conf. But now the board is configured and we can connect it up to the controller. Next step, you will need to power up your BMS board, and it will show a Wi-Fi network called DIY BMS controller. After connecting to the network, I used an application called Fing to find out the IP address of the controller, and if you use your browser to go to this IP address while being in this Wi-Fi network, you can insert the correct Wi-Fi network and so on for the controller to join your local network. And then you also have to find what's the IP address for this in your local network. Now with the controller joined the same Wi-Fi network that my computer is on, I can go to the IP address and get this kind of page. Because nothing is connected to it, it currently can't see any modules because they don't have battery power, and it can't report anything, but you can see the interface, settings and so on. So next up will be connecting the module boards and a battery. Now the wiring is of course important, and the logic here is that you have the controller, and the controller has takes and TX and RX, this is transceive and receive, and this must make a loop through all the modules back to the controller. So let's say it starts from takes transmit, transmits to the receive, transmits to the receive, transmits to the receive, making a circle like this. So I will wire up two modules and connect them to the example battery, which at the moment is my soldering iron battery, which has 4 elements in it. We will just use 2 for the example. And remember, if you have these in the wrong order, then also you will not get anything on the BMS controller. So the polarity here is also important.
But your eye doesn't show anything. Let's try refreshing. Nope. That's the error right there.
Probably some wiring error. Let's troubleshoot. And now on the camera, I of course managed to put the isolator the wrong way around. this is the number 1 leg. It is supposed to go here. I'm sorry if I made you scream at the screen all this time, before I figured this one out, but the one is now working, so let's see with 2. And there we go. We have 2 cells reporting in, and down here we can see 2 temperature readings, but no external ones because I don't have any connected yet. So this is it pretty much, I guess. This is how you solder and connect those up. If you have any questions, leave them in the comments. Thanks. And thanks for Stuart for making these rather nice boards. Oh, and I will add a quick look at my Powerwall first prototype thing that I'm going to use this BMS system on. This has 7 banks, so 24 volt system. Here are the old BMS boards version 3 that I didn't manage to put together. And when my BMS system is complete, I will probably post an update. Maybe someone is interested to see how it works. I will also have these little LED indicators for voltage readout, physical. Oh, and all this is inspired pretty much from Paul Kennett from YouTube, using pairs from salvaged batteries. Here are some of these that are going to be living and working in this battery pack.